Good morning, students. Let's start with the further discussion of the chapter Acids, Bases and Salts. The topic that we have already discussed are introduction, definition of an acid, and classification of acid based on source, molecular composition and concentration. Based on source, we have done inorganic acid and organic acid. Based on molecular composition, we have covered up oxyacids and hydroacids. And based on concentration, we have covered concentrated acid and dilute acid. Objectives of today's topic are classification of acids based on strength and basicity. So we will complete the classification topic today. Also, we will cover up the give reason questions related to the topic above and the preparation of acids. Let's classify the acids on the basis of strength. First of all, we should know that what is strength? Strength of an acid is the measure of concentration of hydronium ions it produces in its aqueous solution. So strength of an acid will be based on hydronium ion and how many hydronium ion it produces. If it produces more hydronium ion, then it will be known as strong acid. And if it produces less or low concentration of hydronium ion, it will be termed as a weak acid. So let's take an example, and the picture is there in front of you. There's an example of strong acid like HCl and weak acid like acetic acid. The acid will be in its molecular form, but when it dissolves in water, it has a tendency to ionize. It can form ions. The acid which can completely ionize and the acid which has a tendency to partially ionize. When the acid completely ionizes, it will form more hydronium ions. Since hydrogen ions are more in this case, so it will combine with water and form more hydronium ion. So the hydronium ion concentration will be very much high. So therefore these acids are termed as strong acids. In this case, there are ions. You can see this red dots and blue dots, but you can also see their molecular form like this. That means in the weak acid solution, there are ions as well as molecule. So the concentration of hydrogen ion is not much as compared to strong acid solution. So therefore, in this case, less hydronium ions will be produced. So therefore, it will be termed as a weak acid. So what are strong acids and weak acids? Strong acid is defined as an acid which completely ionizes in aqueous solution, producing a high concentration of hydronium ions. So we have already discussed this part. Strong acid will be having high concentration of hydronium ion when it dissolves in water. Example, HCl, H2SO4, HNO3. They will produce high concentration because they are completely ionizable in water. Weak acid is defined as an acid which partially ionizes in aqueous solution, producing low concentration of hydronium ions. So in this case, the acid will be in the form of ions and in the form of molecules when it dissolves in water. Example, acetic acid and carbonic acid. Now, let's take a question. Why is dilute HCl acid stronger than highly concentrated acetic acid? Dilute, that means more amount of water is present here, and here it is concentrated. That means it should produce more hydronium ions. But why acetic acid is weaker as compared to HCl acid? Why so? We know that the strength of an acid is a measure of concentration of hydronium ions it produces in its aqueous solution. That how many number of hydronium ions a particular acid produces. So when we talk about HCl acid, we know that it is an inorganic acid and it completely ionizes in its aqueous solution and produces high concentration of hydronium ions. But in case of acetic acid, as it is organic acid, it will partially ionize in its aqueous solution and produce low concentration of hydronium ions. So therefore, dilute HCl is stronger as compared to concentrated acetic acid. The next classification is based on basicity of the acids. What is basicity? Basicity is the number of hydronium ions that can be produced by the ionization of one molecule of an acid in its aqueous solution. So one molecule of an acid, how many hydronium does it produces? That will be termed as basicity. So on the basis of basicity, acids are further classified. But let's first take the ionization of some acids. First, let's consider the ionization of HCl. When HCl dissolves in water, it ionizes into hydronium ion and a chloride ion. The second case is sulfuric acid. When sulfuric acid dissolves in water, it ionizes in two steps and two hydronium ions are formed along with hydrogen sulfate anion and sulfate anion. The third one is phosphoric acid. When phosphoric acid ionizes in water, it ionizes in three steps and forms three hydronium ions, and along with that the anion is formed. When we talk about HCl, one hydronium ion is produced, so therefore it is known as monobasic acid. What is monobasic acids? So the acids which on ionization in water produces one hydronium ion per molecule. Only one molecule is present and it produces one hydronium ion. So therefore it is termed as monobasic acids. In the next example of sulfuric acid, we know that two hydronium ions are produced. So on the basis of this, sulfuric acid can be termed as dibasic acid. Why we are calling it dibasic acid? Because acids which on ionization in water produces two hydronium ions per molecule of an acid. So one molecule of sulfuric acid produces two molecules of hydronium ion. So therefore it is termed as dibasic acids. The next case is of phosphoric acid. We know that an acid, this phosphoric acid is producing three hydronium ions. So it is termed as tribasic acid. So the acids which on ionization in water produces three hydronium ions per molecule of an acid is termed as tribasic acid. Further discussion of monobasic acids will be like, we know that monobasic acids have one replaceable hydrogen ion. So when we talk about HCl, one hydrogen is replaced and it combines with water and form hydronium ion. So therefore it will form only one type of salt, that is normal salt. For example, when sodium hydroxide reacts with HCl, it will form NaCl and water. NaCl, it is not containing any hydrogen or OH, so therefore it will be termed as a normal salt. When we talk about dibasic acids, we know that dibasic acids have two replaceable hydrogen ions. So therefore they form one acid salt and one normal salt. In first case, hydrogen sulfate anion is formed. This particular anion, when it combines with base, it will form an acid salt. And when sulfate will combine with the base, it will form normal salt. So the acid salts are those salts which will contain hydrogen in it. So for example, sodium sulfate and sodium hydrogen sulfate. For tribasic acids, We know that they are having 3 replaceable hydrogen ions. So they will produce 2 acid salts and 1 normal salt. The example is there in front of you. NaOH when combines with phosphoric acid, it forms NaH2PO4, Na2HPO4 and Na3HPO4. The last one is normal. The first two one is the acid salts. We should keep a note that basicity of an acid depends not on the number of hydrogen atoms in one molecule, but it depends on the number of ionizable hydrogen atoms that it has per molecule. For example, acetic acid. Acetic acid has 4 hydrogens, but only 1 hydrogen is replaceable. Similarly, in the case of phosphorus acid, there are 3 hydrogens, but only 2 hydrogens are replaceable. So, on the basis of this, let's take a give reason question. Acetic acid contains 4 hydrogen atoms in its molecule, but it is a monobasic acid. Why so? Let's consider first the structure of acetic acid. It has 4 hydrogen atoms. Very clear. It is there in front of you. And when it ionizes in water, it forms 1 hydronium ion and an acetate ion. Why it forms 1 hydronium ion and why not 4? Because it is containing 4 hydrogens. So what is the reason for this? Because acetic acid molecule ionizes by liberating only 1 hydronium ion. Why does it liberate only 1? Because the hydrogen that is attached to oxygen is ionizable, but the hydrogen attached to carbon is non-ionizable. So we should pay attention that the hydrogen that is connected to carbon is non-ionizable, but the hydrogen that is attached to oxygen is only ionizable. So it produces only 1 hydronium ion. The next question, that phosphorus acid is a dibasic acid. Let's first take the structure of phosphorus acid. Phosphorus acid, in that phosphorus is connected to oxygen through a double bond, and the 2 bonds are satisfied with OH and 1 with hydrogen. You can see the structure in front of you. Now, why does it is known as dibasic acid? Because its molecule ionizes by liberating 2 hydronium ions. Why so? So in oxyacids of phosphorus, hydrogen atom which are attached to oxygen. So you can see there OH, the hydrogen atom that is attached to oxygen atoms are replaceable. They can be ionizable. While hydrogen atoms directly bonded to phosphorus atoms are not replaceable. Let's start with the next topic, that is preparation of acids. The first method to prepare acids is by synthesis method, that is direct combination. The second method is by action of water on non-metallic oxides. The third method with which we can prepare acids is oxidation of nonmetals. And the fourth one is displacement. We can also call it double displacement. So the first method is synthesis. What is synthesis? So the reaction in which 2 reactants react to form a single product. It can be 2 or it can be more than 2 as well, but the product formed is a single product. So that is known as synthesis. So as you know that we are preparing acids and the major constituent in acids is hydrogen. So when we do synthesis, we will take hydrogen and we will add a non-metal into it and we will get our acid which we are concerned with. For example, if we want to prepare HCl, that is hydrochloric acid, hydrogen will react with chlorine to give HCl. So if we want to prepare HBr, then hydrogen will react with bromine, Br2, as they are diatomic in nature. So that therefore we have used Br2 and it will give 2HBr. But we need to note that binary acids, that is the acids that contain 2 elements, can only be prepared with this method, not more than that. The second method by which we can prepare acids is by action of water on non-metallic or acidic oxides. So the oxides of non-metal, when react with water, they form acids. Acidic oxides are also known as acidic anhydrides. What is an anhydride? Anhydride means a compound formed by removing water from a more complex compound. For example, if we have sulfuric acid and from that if we remove water, we get SO3. SO3 is known as acidic anhydride in general. So therefore, a compound from which water is removed and the leftover compound which is there, that is known as anhydride. So let's take up an example. Acidic oxides react with water and form acid. If we have SO3, that is sulfur trioxide, when it reacts with water, it forms sulfuric acid. SO2, sulfur dioxide, when reacts with water, it forms sulfurous acid. CO2, that is carbon dioxide, when it reacts with water, it forms H2CO3, that is carbonic acid. When P2O5 reacts with water, it forms phosphoric acid. So remember, these all acidic oxide. This particular reaction is very important. And we need to note that only oxyacids can be prepared by this method. The third method is by oxidation of non-metals. For example, if we take sulfur as a non-metal and with that we react nitric acid, that is a concentrated nitric acid, we will get sulfuric acid. Sulfur is present, sulfur oxidized and it forms H2SO4. As nitric acid is concentrated, so NO2 gas will also be liberated. Same way, if phosphorus reacts with nitric acid, it will form phosphoric acid. The fourth method of preparation is double displacement. What do you understand by double displacement method? So a reaction in which two compounds react by an exchange of ions to form two new compounds. So both the cation and anion change their places, and therefore this method is known as double displacement method. This method is also known as, in this particular chapter, as a preparation of volatile acid from a non-volatile acid. We already know what is volatile. The acid that can be easily evaporated because they have low boiling point, and non-volatile, the acid which have high boiling point and which cannot be easily evaporated. For example, if we react a salt with non-volatile acid, it forms a salt and an acid. Let's take an example of NaCl. If we have salt like sodium chloride, when it reacts with sulfuric acid, because sulfuric acid is a non-volatile acid, it forms NaHSO4, that is sodium hydrogen sulfate, and HCl. What happened here is, this Na is positive, Cl is negative, and hydrogen here is positive and sulfate is negative. Sodium reacts with this sulfate and hydrogen goes with HCl. We know that H2SO4 ionizes in two steps. We have already done that part. So accordingly, HSO4 is formed. Depending on the concentration, we can also get Na2SO4. NaNO3, H2SO4, when these two react with each other, it will form nitric acid and sodium hydrogen sulfate. From the help of today's topic, you can solve the questions which are flashing on your screen.